Okay, good morning. It is audible. आवाज येतो का माझा? ओम. ठीक आहे. Just a second. Just a second. Okay. So last lecture we go with the uh, pipeline concept. The pipeline concept is related with the implicit parallelism. So we know that implicit so we know that implicit parallelism we learn in last lecture related with the concept of so what we say that the implicit parallelism is automatically exploited by the compiler and interface. The objective of implicit parallelism is the parallel execution of code in the runtime environment. So we try to execute the number of tasks in the runtime environment. So we're taking some of the example of related with the pipeline and some concept related with the multi-threading, vectorization, and some of the program languages of the implicit. Now we go with a physical uh, organization of parallel platform. So how the physical organization of platform will be considered with that one parameter will be uh, evaluated here. So considering this parameter, the physical organization of parallel platform, the logical uh, just a second. The logical organization refer to be a program's view of the platforms, while the physical organization refer to be a actual hardware organization of the platform. We know that the physical parameter related with the uh, actual conduction of that. Uh, please mute your camera so it can be a properly bandwidth will be available. So logical organization refer to be a program view of the platform. Now, just we know that logically we assign, but physically we it requires some actual hardware and how it can be interconnected with that. That things need to be considered for the uh, logical and number of parameters, right? So the two critical components of parallel computing form are programs. The perspective are ways of expressing the parallel task. It may be considered with the control structure and the mechanism for the specifying the interaction between this task communication model. So regarding this way, we try to explain that uh, how the physical interconnection will be done in a parallel platform. So basically, there are two parameter will be considered. One is the static network and dynamic network. Just look out diagram. So I make a pencil. So this will be a static diagram and this will be a dynamic diagram. So these are the two way we try to make a interconnection of number of network for the platform parallel platform. Considering this parameter, uh, the, the two critical components of parallel computing form a programs. The perspective are always expensive related with that one. So we discuss the physical architecture related with a parallel mechanism. First, we start with the ideal architecture and then outline the practical difficulties associated with a releasing model. The interconnecting network for parallel computers. The first is related with the interconnection of networks, provides the mechanism for data transfer between the processing model or the between the process and memory model. So we know that we observe the general central processing unit, then general purpose architecture, that is cache based microprocessor architecture. In that we know that we can access the data from memory and the number of devices are connected to the memory. It may be a considered central processing unit, input output devices and other peripheral. So the physical network will be required to interconnection between the number of peripherals and memory. So how we can access that one? So there are actually two types, that is a static network and dynamic network. In a static network, just look out that the number of peripherals, that is a P is a peripheral 1, peripheral 2, peripheral 3, peripheral 4, or we say that number of processor that will be interconnected with a networks. They are interconnected by network interfacing switch. Specifically, they are connected by interfacing network interfacing switch, or they are linked, and the network of this interconnection is called as a static network. Same like in dynamic network, there will be a dynamic allocation of peripherals related that, and they are interconnected by the switching element. They are interconnected by the switching element. So the peripheral 1, peripheral 2, peripheral 3, peripheral 4, or the processor are interconnected to each other by the different way. So considering this parameter, uh, the physical network is mostly used to interconnect the number of devices to, or number of network to the each other. So that concept we try to explain this way. So the interconnecting networks are built using a link. So they are interconnected. We know that what is a network. So a network is nothing but either interconnection of two or more than two devices or peripheral. We know that about that one. So these are connected by a communication that is called as a link, right? We know that will be a link, and this form the one network. So this is a network one, right? So interconnection network are built using a link switches. A link um, correspond to the physical media such as a set of wire or the fabric cables or carrying the information. They used to make a communication between the two nodes. So interconnection network can be classified as a static or dynamic. We know that it is classified as a static or dynamic. In static network, it consists of point to point communication link among the processing nodes, are also referred as a direct network. So static network is also referred as a direct network, and it is a point to point communication. In dynamic network, it also known as a indirect network, or we say that dynamic allocation of the interconnecting are built using a switch and communicating links. So just we observing this parameter, just we observe here. Just I remove this one so you can getting properly. So just we go with that. Just look out that those static network are directly point to point connected. They are point to point connected to each one, and so we say that it is a static. And a dynamic network are allocated dynamically, randomly. They are allocating each one, and both purpose is to make a communication between the processor to the processor to execute the number of instruction. So that will be a consider with a this parameter. So dynamic network is also known as a indirect network, and static network is also called as a direct network. So that concept will be a clarify here. So next important question is related with a That is important. In exam point, most of the time this question will be asked the superscalar architecture. That question is most time the asking about the superscalar parameter. So considering with the superscalar parameter, just second, it consists the set of instruction what want to be we executed by a processor. So we make a instruction each unit, one unit which have contained a number of instruction, which will be contain the number of instruction. After that, we create one a queue of instruction. We create a queue of instruction. It is like that. First instruction will be executed, then second exam will be executed, then third, then fourth, fifth, sixth, seventh, as per the execution, whatever we design the model. So first we make a group of instruction which will be a store into that. We say that each unit, and we create a one queue of instruction and that executed one by one. So after that, there will be a dispatch unit. That dispatch unit which can be carry the your whatever the instruction to the process. So after the dispatch unit, we go with the two separate parameters. One is a floating point unit, and second is a integer unit. And lastly, we go with the write unit. So write unit is nothing but your output, actual output. So just look out how to make a faster communication. For that, they use the two different unit. One is a floating point unit and second is a integer unit. So floating point calculation will be done separately. That is one instruction. And integration, integer type of calculation or process will be done by separate by integer unit. So what will be done in a super architecture? Uh, the such processor are capable to achieve an instruction execution through a, just a second, I will remove this one. Just I remove this one. Just look out. Hmm. So it executes throughout of more than one instruction per cycle. So how it can be will be increase this parallelism? It execute throughout of more than one instruction per cycle. So he execute is like there are two uh, instruction. One is related with a floating point and second is related with integer type. They executed simultaneously in a single cycle, right? These are known as a superscalar processor. So here only given the two example, two instruction. There may be a 3, 4, 5, 6, 7. Multiple instruction they are executed simultaneously. The fetching unit will be fetch the instruction whatever you added here. Suppose I add third ball is a related with a logical. So the another unit is connected here logically. So in the above diagram, there is a process with two execution unit, one for the integer and second and one for the floating point operation. The instruction fetching unit is capable of reading the instruction at a time and start them in a instruction queue. In each cycle, the dispatch unit reactive and decode up to the instruction from the, just I remove this one. Yeah, every time this will come, right? So a multi-core processor is a single computing computer which can be a two and more independent actual processing unit. So considering this parameter, just I go with here in this, right? So dispatch unit will be a collect the data from instruction queue and decode this data and pass to the next instruction. That is a floating point unit and the integer unit, and both are work simultaneously. So it can be a produce the output. So what will be that we execute multiple instruction at the same time. That is the purpose of super architecture will be used for the you are making a parallel computing. So considering this parameter, it is called as a superscalar architecture. Parameter related with that things. That is superscalar architecture. Next, considering with that uh, uh, related with the different things, this called as a multi-core architecture. So what is a multi-core architecture parameter? So in multi-core architecture, we use a number of processor. So we know that in first lecture we learn about that this will be a one processor, this will be a second processor, and this will be a third processor, and this will be a fourth processor, right? So we say that core 1, core 2, core 3, core 4. So they have a register file to store the data. ALU, that is arithmetic and logical unit, which perform the arithmetic and logical operation with bus interfacing, which are interface with each processor. Same like that, the core 2 having a register file with ALU and interfacing. Core 3 having a register file ALU with bus interfacing. Register file core 4 is a register file ALU with that one. So what will that? A single architecture which having a multiple core, or we say that multiple processor. That will be called as a multi-core architecture. That will be called as a multi-core architecture. So that how it can be a work. Just I clarify. Just removing this. A multi-core processor is a single computing component with two and more independent actual processing unit called as a core, which have a two and more multiple independent processing unit. So, which are then unit that read and execute the program instruction. The instruction are ordinary CPU instruction such as add, move, data, and branch, but the multiple core can run multiple instruction at the same time, the increasing overall speed for the programming and parallel computing. So considering this parameter, we know that so this will be a one processor which handle the multiple instruction. This also handle the one multiple instruction. This will be handle the multiple instruction, and this also handle the multiple instruction. So to handle the multiple instruction, we create a one processor which contain the number of processing unit, that is called as a multi-core. So that is the concept of multi-core architecture to make execute the number of instruction simultaneously. So this will be handled some of instruction, this will be handled some of instruction, this will be handled some of instruction, this will be same parameter those we learn in a first lecture like this one. Just I explain this pair. Just look out a problem which divide into a number of instruction, and then again the number of instruction are divided into a number of CPU. So this is the processor 1, processor 2, processor 3 is like. So it is called as a multi-core. Multi-core. So number of instruction are executed the simultaneously. So that parameter we consider with a multi-core parameter. That is a multi-core architecture. In superscalar architecture, we use a different unit to execute the different instruction simultaneously. Here, multiple processor are used. Multiple processor are used, just look out here, to execute the multiple instruction. So that way we go with the controlling of the your register parameter, right? So that is concept related with the superscalar architecture and related with the multi-core architecture.